Hey everyone, good morning. I'm Priyanshu Agrawal and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is partition array according to given pivot. Okay, so let's see what is this question and how we can solve it. So in this question, you are given a zero index integer array nums and an integer pivot, and you need to rearrange nums such that the following conditions are satisfied. Okay, so let's see those conditions. Every element less than pivot appears before every element greater than pivot. Okay. Every element equal to pivot appear in between the elements less than and greater than pivot. And the relative order of the elements less than pivot and the elements greater than pivot should be maintained. Okay. And more formally, consider every pi pj, where pi is the new position of the ith element and pj is the new position of the jth element. If I is less than j and both elements are smaller or larger than pivot, then pi is less than j, and you need to return nums after rearrangement. So what we have been given in the question is a nums vector and a pivot, and you need to rearrange the elements of the nums such that all the nums less than pivot should appear before all the elements greater than pivot, and all the elements equal to pivot should appear between the elements less than and greater than. Okay, so let's see this thing in this test case. So you have been given the pivot as 10 and these elements. So like 9 is less than 10, yes. 12 is less than 10, no. 5 is less than 10, yes. 10 is less than 10, no. 14 is less than 10, no. 3 is less than 10, yes. Okay, so these are the elements which are less than pivot, so they should occur first, and then the elements which are equal to pivot, and then the elements which are greater than pivot. These are 12, 14, yes. So in this way you need to rearrange the elements of the nums and find your output vector, considering the case when the relative order of the elements should be remain same. They should not be changed. As you can see in the example, 9 occurs before 5, 5 occurs before 3, and in the output vector also 9 occurs before 5 and 5 also occurs before 3. Okay, so the one very basic brute force approach you can think of, like you can start iterating in this nums, and you have also initialized our output vector, let's say result, and you have started iterating in this nums. What was our nums? 9, 12, 5, 10, 14, 9, 12, 5, 10, 14, 3 and 10. Okay, so let's say you have started iterating in this nums. So first you will start iterate and then check for the elements which are less than pivot. So pivot is 10. Okay, so you will start iterating in this and we check 9 is less than 10, yes, so you will push it in your result. 12 is less than 10, no. Escape. 5 is less than 10, yes. 10 is less than 10, no. 14, no. 3, yes. 10, no. Okay, now in the second iteration we will check for the elements which are equal to pivot. Okay, now again start iterating from the starting. 9 is equals to 10, no. 12, no. 5, no. 10, yes, so push it in our result. 14, no. 3, no. 10, yes, so push it in our result. Okay, now we will do one more iteration to check for the elements which are greater than pivot. So again start iterating in the nums from the starting. So check for 9, no. 12, yeah, 12 is greater than 10, so let's push it. 5, no. 10, no. 14, yes, 14 is greater than 10, so let's push it in our vector. 3, no. 10, no. Yeah, we have got our result. So what we have done? We have done 3 iterations in our nums, in which first was for checking for the elements less than pivot, second was for checking for the elements equals to pivot, and the third was for checking for the elements greater than pivot, and then we have got our result. So the code for this approach is very simple, like as I have explained. First, in first iteration we are checking for elements less than pivot and pushing it. In second we are checking for elements equal to pivot and then pushing it. In third we are checking for elements greater than pivot and then pushing it. So the time complexity for this approach will be go of 3n, as we are doing 3 different iterations, and its space complexity will be go of n, if we consider the space of this output vector. Okay, this 3n is okay, but can we do this thing in a single iteration? Okay, so let's see if we can do this thing in a single iteration while not increasing our space complexity. Okay, so can you think this question something like in which we need to arrange all the zeros together and then all the ones together, and in this question also we need to arrange all the less than values in the left and greater than values in the right and equals to values in the end. So if we leave these equals to values, so we need to arrange less than values in the left and greater than values in the right. Okay, so in this kind of question, when we need to arrange all the zeros together and ones together, we use 2 pointers to arrange this. So can we also use these 2 pointers for arranging the less than and greater than elements? Okay, so let's see if we can arrange our elements with the help of 2 pointers. So the array was 9, 12, 5, 10, 14, 3, 10. Okay, 5, 10, 14, 3, 10. Cool. So now let's initialize our 2 pointers, one from here I and one from here j, and let's initialize our result. Yeah. So for our result, our first left pointer is pointing to the starting and our right pointer is pointing in the end. Okay, so what we will do, we will check if I is less than the pivot is 10. Yes, it is less than the pivot. So we will simply store that element in the result of left and increment our I. Okay, cool. And also check whether the element which is stored at j is greater than pivot. No, then what we will do? We will simply decrement our j because we are just checking for the less than and greater than elements for now. Okay, so now again check with the 12 is greater than 10. Okay, so should we keep it here? And 3 is less than 10, so should we keep it here? Okay, but can you say like if you keep these elements here, then you will not be able to satisfy the case that the relative order of the elements should remain same. So this will get distorted then, because then there is a 14, so then 14 will come here. So 14, 12 is not the right order, 12, 14 is the right order. And here also 9, 5, 3 is the right order, not 9, 3, 5. So no, so that's why we will not do this thing. Our I pointer keep track of the less elements only, and our j pointer will keep the track of the elements greater than pivot only. Okay, so let's see. Okay, 12 is greater than 10, let's skip it. 3 is less than 10, let's skip it. Increment our I pointer and decrement our j pointer. Cool. 5 is less than 10, yeah. And when we update this result of left with this some value, then we will also increment our left pointer. And now we have got 5 is less than 10, then we will simply store 5 in our left pointer and update our left pointer. Okay, and now we will check whether 14 is greater than 10. Yes, so we will store this in our right pointer and then we decrement our right pointer and then decrement our j pointer. Cool. 5 is less than 10. Also we have already checked for that 5, so we must have increased our I pointer as well. Okay, so now I and j are at the same point. Okay, let me just write it again so that it will not create confusion. 9, 12, 5, 10, 14, 3, 10, 14, 3, 10. So right now I and j pointer both are here and our result is 9, 5, 14. And our left pointer is pointing to here and our right pointer is pointing to here. Still there are these positions left. Cool. Okay, so now our I and j pointer are both pointing to 10. No worries, just check whether they are less than pivot or greater than. No, they are equals to. So just increment our I pointer and decrement the j pointer. Okay, now again check 14 is less than 10. No. 5 is greater than 10. No, so let's just increment the I pointer and decrement the j pointer. Now again check 3 is less than 10. Yes, so store that in the left pointer, increment the left pointer, increment the I, and check for j. 12 is greater than 10. Yes, store it in our result, increment the r pointer, decrement the j pointer. Now again check, 10 is less than 10. No, increment I. J is less than 9 is greater than 10. No, decrement j. Oh, so we have ended our iteration because our I and j goes out of bounds now. Okay, but now we are left with some places. So what we can do, we can simply run one more loop till left is less than or equals to right, and simply store result of left plus plus with pivot element, because these places are supposed to be filled with the pivot elements only. Okay, so let's try code this approach so that you will get a better idea. So let's store the size of the nums in n, and let's create another vector result of size n. Let's initialize it values 0. Or one more thing we can do is we can initialize this vector with the pivot values only, so that we don't need to do this iteration. Then we will be able to eliminate this iteration. Okay, now let's start iterating. Let's initialize two pointers, I equals to 0 and j equals to n minus 1. Cool. Now while I is less than n and j is greater than or equals to 0, I, and we need to check if nums of I is less than pivot. Then what we will do, we will simply update, and we need to initialize two more pointers, int left equals to 0 and right equals to n minus 1 for this result. So we will simply store that element in the result and increment the left pointer, and if nums of j is greater than pivot, then we will simply store that element in the result of right and increment the right pointer, and the remaining positions will be filled with pivot as we have initialized the result with the pivot. So what we can do, we can simply return our result. Okay, so let's try run this. What happened? Nums of I. Oh, I have forgot incrementing I plus plus, and then j minus minus. Cool. Yeah, let's try run this again. Right also minus minus. Yeah, why, I don't know why I'm doing so silly mistakes. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about the time and space complexity for this approach. So as you can see, we are just doing a single iteration only. So the time complexity for this approach will be big O of n, and space complexity will also be big O of n if we consider the space of that result vector. So see, in this approach we have reduced the time complexity from 3n to 2n with the help of two pointers, right? Okay, so this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.